No. Doesn't quite work that way because we lab each week, but the summer schedule doesn't work that way because it runs on 6 weeks. So the lectures are 65 minutes. And then I don't have, basically I have to go very quickly through my lecture. During the semester, it's only 35 minutes. If you look at all the posted lectures, they're always about 35 minutes, and that's because with announcements and my clicker questions, that's how much time the lecture period has. So this just allows me to actually like go through stuff a little bit in more detail and slower. So it's a good thing, but and show more examples and stuff like that. The way that the lectures that are posted are set up is that they're intended for people to go back and rewatch because they're not going to be able to do it all in the lecture period or like digest it all. Okay. But so we're going to start lecture here. For those of you who are remote, we have 3 students in class and the rest of you are going to be online. So I'll be posting the lectures on D2L. They won't be posted until probably later in the day on Monday and Wednesday, but you can always watch the ones from previous semesters, which are already posted. The purpose of re-recording each lecture is for you guys is just so that you can have any announcements or anything that we're talking about that's relevant. And as we were just discussing, the summer lectures will be a little bit longer because we have that luxury, so I'm probably going to go through more examples. They'll definitely be a little different than the ones that are posted for the semester course. So I'm going to start today by just doing a quick overview of how the course is going to run, but we are going to start topic 1 today. So I always like to start with just an introduction about myself, and then I'll have you guys introduce yourself too. So my background is in computational fluid dynamics, primarily in ocean modeling, and a lot of my research has been around the development of numerical methods. So my little area in mechanical engineering is very, very numerical and mathematical. So you can see that my degrees, I have an undergrad in math as well as in mechanical engineering. And I also just like to post like what other universities and industries that I've been affiliated with in case you're interested in any of these places. I'd be happy to talk to you about any of them. I can't tell you how many people I've advised on graduate school at CU Boulder. It's a pretty common path for people coming from MSU. So I did 5 years, my master's and my PhD there. So, and then here's just some animations of my work, and actually they were all done in MATLAB. So this is a post-processing script that I wrote in MATLAB. This is 2, and this is volume rendering, which we don't do in this class, but it's kind of new. It doesn't work super well in MATLAB, but they just started to develop it a little bit more recently. And then this is, and I'm not going to explain like what I'm studying here because I could go on and on, but this is an experiment. So this here is just an image of some dense water flowing down a slope, basically. And then this is actually our MATLAB visualization of a numerical simulation, and we were just trying to match it. So we did a lot of like development to color match it. So all of this is done in MATLAB. This is the only thing that's not mine. This is through the Lanel MPass software. Okay, so what I'd like to do now is have you, oh, I didn't bring the card, so just grab a piece of paper. Sorry about that. Just grab a blank piece of paper, and if you could just fill out some of this information about yourself, and for those of you here, just do it on a piece of paper, and I'll come get it from you by the end of the class. For those of you who are remote, you could just go ahead and email me this, the answer to these questions. This is not for any reason other than it's really helpful for me. I have been doing it now for many semesters, and I really appreciate knowing these types of things. So. You guys get enough time? Okay, and it is also helpful for me to just, I think everyone has one though, the last time I checked. But if you have a photo uploaded on D2L, it just helps me learn your names quicker. So if you don't have one, that'd be great if you could post one. You just go to the, like you click on your name or your photo in the top right-hand corner, and just add it through the profile. Yeah. Okay, so I'm just going to go over some background in the course. The syllabus is posted, and a lot of people have trouble finding it in this location. Did I include it in the news item, how to find it?
Yeah, but it's also in the overview. You can't really print it out.
Yes, that's intentional.
Really?
Yeah.
Okay.
Yeah, so I don't like, it doesn't matter for this semester, honestly, but I just generally like to have one place where you can find the syllabus, because it does change, or things get updated. And so because it's like technically a contract kind of like of what we're both agreeing on, it's always subject to change with schedule changes. And so I just like to have it in one location so that people aren't looking at a wrong version. But you can find the syllabus by clicking on content and then on overview. I'll show it when I go into detail in a second, just to make sure. But what we're going to be doing in this class, and this is your first class in a series of computational classes. And so the goals of this particular class is to learn the basics of programming. So it assumes that you've never had any programming experience coming into the class. I think that's one thing that a lot of students come in very nervous about, because some people take programming in high school or have taken other programming classes. But I survey my class. I'm not going to do it this year, this summer, but basically like 85 to 90% of students have never ever done any programming, and like almost no one has ever used MATLAB at all. So that's the goal of the class, is to become, to be introduced to programming as a skill set, but then also to become proficient at using MATLAB. MATLAB is more than just a programming tool, it's a whole computing environment. And so everyone becomes very proficient at using MATLAB, which is very important for engineers because it can really help you in so many different ways. And then as a way to be able to do both of those things, we need to look at something, right? So what we're looking at in this class is some basic numerical methods like derivatives and integrals, as well as some different data analysis tools. I've changed the applications several times. So the ones we're doing this year are calculus, like derivatives and integrals. We're doing linear algebra, optimization, and interpolation. So a lot of these you will, when you move on to 303, you're going to do them all in a much more higher order complex way. So you're kind of just feeling them out in this class. We also, because you're learning to program, we just program some basic, like, typical computer science algorithms as well to get a feeling for all of the different ways and tools that we can use for programming. So in the curriculum, the only prereq is 103, but it's not a curricular prereq, so this has nothing to do with CAD. It's nothing like CAD. It's a totally different class. So it's not, don't have any expectation that it will be like that class. The co-req is Calc 2, and that's why I can't do any engineering analysis like statics or dynamics or thermo or anything for our applications because it's not required to take this class. And then from here you move on to 303, and then the course catalog. This might not be your current course catalog, but eventually it's going to be required that after you take 303, you're required to choose between 405 and 436. 405 is FEA, which is like computational solid mechanics, and then 436 is CFD, which is computational fluid dynamics. So they're just basically applying all of this programming and computational to fluid and solid mechanics. So here's what you need for the class. There is a textbook that I've tied to the class. So if you look at this overview of topics, which is posted under assignments, it's the first thing, it's not in another folder. This ties to this textbook. So if you look at the top of every topic, it links you to extra practice problems and reading from this textbook. I've been using a version of this textbook for like 5 years, so it's really well tied. However, students repeatedly have said, and they say this in every class, that the textbook was not useful, they didn't use it, so I've made it optional because MATLAB is very, very available, like help is very available online. So if you don't want it and you don't need it, then you don't need to use it.
I have a question. Would you still use the book for 303?
No, it's a different book. Yeah, you use a numerical. This is a programming and MATLAB book.
Okay.
And the book you use in 303 is a numerical methods book. And there are previous versions of the book as well that would probably be more affordable, like if you buy it on Amazon. The course packet this summer is just posted on D2L, so you don't have to buy it from the bookstore like previous semesters do. So if you just go into assignments under content, I've just posted all of the things that are in the course packet that's normally picked up. This is for 2 reasons. One, there's not very many of you, and so you can just print them off and just pay for the printing cost that way. When they pick it up at the bookstore, they're just paying for printing costs. It's like $5 for the whole thing. So you can just do that on your own. You can even probably just do it in lab right before the next session. You just print off whatever you need. But then also for the online students, I've posted them, obviously, because you need them digitally. And then I've posted Word formats so that if you want to submit them in Word after you've filled them out, you can do that as well. I've only done that with the pre-lab because that's the only one that you have to fill something out with. You need to download MATLAB on your computer. technically you can just use computers on campus, but I think almost every student prefers to have a copy. So there's a link in the syllabus of where you can download it. There's a site license, it's free for all students. And then D2L, and again, most people do prefer to have their own laptop instead of switching files back and forth from the lab computers. So this is the format of the class. So every lecture, or every topic starts with a lecture, and again, I think this time might depend on how this goes. We'll see how long that will take. But it starts with a lecture. You move on to a pre-lab. So the pre-lab is posted under every topic, and it's not like a typical pre-lab, but I've called it that because here at MSU it seems to be the clearest way to make it obvious that you need to do it before you come to lab. So I've called it that. But what it is it's a worksheet that has you walk through several exercises in MATLAB, and it has you redo some stuff that's done in lecture. But like I said, I'm not able to show you how to do everything in MATLAB in lecture. There's way too much that you could do, too much customization, too many different functions. So this gives you another avenue to do that, but then allows you to do it yourself. And these are simpler than a lab where you have to actually program something up. So you should be able to complete the entire pre-lab just from the lecture notes and from using the MATLAB help. So sometimes I won't show you exactly how to use a function or a intrinsic feature of the code, and so part of this class is to learn how to figure that out, because the most important thing about using MATLAB is that you will never be told how to use it when you need to use it, ever. You know, you're always going to need to figure it out. So part of this class is to learn how to figure that out by getting used to the help and getting used to Googling things, and kind of figuring it out. And I think that's probably very different for some people. After you finish the pre-lab, which students have told me takes between 1 and 2 hours, so if you're planning from remote, that's how long you should expect to take. Then you complete the lab, and the intention is that you do the lab during the lab period. So for us, that's going to be from noon to 2 on Monday and Wednesday. You should be able to finish the labs during that time. But if you don't, then you can turn them in by midnight that night. And because of the fast acceleration of this class, I think we need to finish them. So we can't keep pushing them off because there's just no time. And everyone does these things at very different paces. So we're just going to need to check in with each other a lot and look at how this is going, because I've never run this in the 6-week series. So the labs for U3, you're going to show me your lab in the lab period, and I'm going to check it and make sure it's all right. And then you'll submit your lab to D2L under the submission folder. For remote students, you're just going to submit your lab, and I'll check it more in depth when I open up the file. Okay, so then the new thing that I'm doing instead of quizzes is there's this MathWorks feature called Cody Courseworks. And what I'm going to do is I'm going to set up, at the end of every week, I'm going to set up these simple exercises that are based off of what you did in lab. So there's a lot of syntax and complications with labs usually that you have to get used to, and that I help you with. You know, it's just about like figuring out the syntax basically. So Cody Courseworks is a way that we can just check in so that we can make sure that we're all on track for when the exams come up. And they're all done on this web-based platform. So you just basically work out the exercise in MATLAB, and then you submit your code to the platform, and it grades it for you. I wrote all of the exercises, so I wrote how it's graded. So I wrote like what I'm checking, like did you get this variable quantity correct or whatever it is. And it's really cool because you can see how you're doing compared to other people. So it doesn't really happen until like mid-semester, but you can see who wrote the best code. Like if it's you can't see who wrote it. You can just see if you wrote it, like who wrote the most condensed code, who wrote the most efficient code, and then you can see how many times people submitted failed codes and completed codes and stuff like that. They're very straightforward compared to the labs, but it just gives me a way of just checking in on that kind of stuff. And yourselves. So those are going to have a really flexible due date. I don't know exactly when it'll be, but ideally you will have finished like 3 of them before the midterm and 6 of them before the final, basically. Do you have any questions?
Midterm in 3 weeks?
Yeah, I know, it's insane.
So then we're up to 30 courseworks per week after that.
Just 1. There'll be 1 per week. Is that what you mean?
Because you said there were 3 and then there were 6.
Oh, I meant, 6 total.
Oh,
So
okay.
hopefully you have them all done before the final.
Okay.
Yeah. This is the way that the grading is going to work. So Cody coursework is going to be 15%, but again, it's unlimited submissions. Maybe not again. I don't know if I said that. It's unlimited submissions. It's untimed. So, you should be able to get all the credit if you do it. And then the MATLAB binder is 35%. That's also just graded for completion. So you get a 0, 1, or 2. 0 means you didn't show me anything. 2 means you are pretty much done. You don't have to have everything perfectly right to get a 2. And then a 1 means that you're missing a significant portion of the assignment, which means you didn't do part of the assignment. So if you attempted everything, you usually get a 2. And then the exams are worth 50%. So any class like this, which is a skill-based class, skills just take time. That's all they take. You just have to keep practicing and doing. So I really advise you to be very thoughtful about how you're using your time this summer in this class, because it could really, really help you. You come in, you watch lecture. My intention is that the period between now and lab, you do your pre-lab, you just finish it, you come into lab, do your lab, and then you move on. And it's just time. You just have to do it. And the nice thing is that there's not very many of you, so I'm going to be very available to help. I don't have office hours specified, because I was assuming that because there's so few of us in lab that there should be plenty of time to answer any questions or to go through anything like that. For remote people, I'm really good at responding to emails, so just email me at any time. I can respond usually very quickly. So that's the first thing, is just take this time and just do it wisely. Don't waste it. And then the second policy that I want to make sure that you're aware of is that the exams are all handwritten. You can't even use a calculator on the exam. And so just be prepared for that. That means that I'm not grading exams for like very, very specific syntax or missing a period or anything like that, because you can't check it either, So I'm looking more for the development of algorithms and that you're aware of things you should be aware of by now and stuff like that. And for all remote students, you do need to arrange for your exam to be proctored by a testing center, and so make sure you check out the schedule for when those are happening. This is the part that I really hate, but I do have to mention this. I think it's important that all of this language is in the syllabus that you can read, but this class is particularly hard for students to understand what is considered academic misconduct. So I just like to lay it out so that you know what it is, so that you have the expectation. But basically, collaboration is allowed on pre-labs and labs for students that are taking, pretty much any student. Collaboration means that anyone can help you by explaining things, pointing things out, writing up explanations, doing a demo for you. Anything like that is allowed. However, the one thing that is not allowed and is considered academic misconduct for any work in this class is the sending and receiving, using or copying of any file that is not yours. That is not allowed. So that includes previous semesters, that includes things online, just taking verbatim code from online. There is nothing in this class that requires you to do that. Some classes, when you start writing computational, when you start solving computational work, that is okay because there's no reason to reinvent the wheel if someone else has already done it. But everything in this class is to reinvent the wheel because that's where you have to start. You can't start anywhere else. So I just want you to know that anytime you send or receive a file to someone else or from someone else, that is considered academic misconduct. There's going to be no collaboration on exams. Cody coursework, I don't have it in the language, is going to be the same policy as pre-labs and labs. So you're allowed to collaborate with whoever you want. There's not it's not like you have to do individual work on that. And so just so you know, all of your files get submitted through Turnitin on D2L. And Turnitin compares your file to every other student who has submitted a file to me, as well as any student who has submitted a file at any university, as well as anything on the web, anything posted to the web. And it's actually very good. And so, unfortunately, I have received files in the past that just were 100% match of someone else's file, and I am, by the university policy, required to report that to the dean of students. I have no choice. So I like to hear what happened, and I'm definitely not I have no judgment on people who make a bad choice or whatever, but I do have to report it. So just know that I don't have a choice on that. So what happens when it gets reported? The first report to the dean of students for academic misconduct is just a warning, so there is no consequence. But there is a consequence in my class that you get a 0 on the assignment. Second instance is just a failure of the course, and it usually, when it's reported to the dean of students, it results in suspension. It can result in suspension. So I would suggest not doing it. But I have to say this, it's really sucky. I actually have very few problems with academic misconduct, but usually towards the end of the semester when people are getting tired and exhausted and stressed, that's when it happens, and I understand. But just don't do it because I don't want to be the one. I don't want to deal with it. Do you know what I mean? I just don't. It's not fun. So that's that. So then here's the schedule, and this is important that you pay attention to this. So you'll see that we have 5 topics before the midterm, and the midterm is going to happen on a Friday during our lab time. And that's because Memorial Day took one of our sessions away, and we have to have 12 sessions. So we're going to do the midterm that day, and then the final exam is Friday, the same time, the last week of class. So those of you who are taking the exam remotely, you need to contact me and schedule that in a testing center at that same time. And then I will arrange with the people at the testing center the receiving and to give them the exam and for them to give me back your exam. So, and the exams will just be in this room. I don't think I mentioned, but the exams you get to use a crib sheet, so you can use 1 for the midterm, 2 for the final, front and back side on both. You guys have any questions about any of that? I don't have the Cody coursework deadlines on there because I'm going to be pretty flexible about them, so you'll just see those. I'll invite you guys to the Cody. I think that this Cody coursework is new, and I was just trained in it 2 months ago, and I'm a little bit nervous that it's going to be confusing at first because when you first starting to use MATLAB, you're still figuring out what the M file is, what the command window is, what's what, and then you have to go into Code coursework and it doesn't use MATLAB, you just submit the code to it. So I'm pushing it off just a little bit, but we'll start it probably I'll show it to you on Wednesday, I think. So one thing I just wanted to point out, and this is really interesting for you guys in the summer class, I think, is that my students don't miss class. Like, that's how you are successful in my class, is you don't miss class. Because everything happens in class, you know? Like, there's actually very little work outside of class. It's just finishing everything that you were doing in class. So you can see here I have 45 students, this is from the fall, that missed 0 days of class, which is that's a lot of students actually. And you can see their final grade average and their final exam grade average. And then it's just like, just a progression. Part of it is because there's a lot of like, a lot of the grade is, like this grade here, is participation or just like that they turn stuff in, and if you miss class then you miss the quiz or whatever. But even the exam grade is also reflecting that. Oh, I don't think this is really relevant for you guys, but I always post my grade distribution from the last semester so people can see, because I think people get this like fear that no one does well in the class, but actually people do really well in the class. This last semester, I had like 20 A's and there was only like 80 students. So if you just do what I tell you to do, do fine. And that is how skill-based things are. You know, you just have to do it. And it's not hard. It's just practice. So, you guys want to take a break? You ready to start? Just rearing to go?
Here we go.
Okay. Okay.